to move to section 8.5. It says properties of logarithms. Logarithms have some kind of cool properties that allow you to solve. You just gotta know what they are. They're really not a big deal if you know how to use them. You guys can solve basic equations. You can multiply. You can do these properties of logs. You just gotta know the basics. And we're gonna do that. All right. There's a couple of properties that you guys need to be okay with. And this logarithm, first of all, 5 times 6, we call that our argument. In our argument, we're multiplying two things. I really can't do anything to solve this, but there is a property that says that we can write this out in expanded form. What we would do is we would say log base 2 of 5 plus log base 2 of 6. If you're multiplying your arguments, we can write out an expanded form using two logarithms, and we would be adding those two. Now, there's another time when we multiply, we add in algebra. Do you remember? Exponents. Remember your exponent rules? If you multiply your bases, you add the exponents. Okay, maybe that'll help you remember that. If you're multiplying your arguments, we're going to add our logarithms. And then there's nothing I can do right here. Okay, I don't know what log base 2 of 5 is, and I don't know what log base 2 of 6 is, so I can't do anything else. But just to demonstrate this property. There's another property, well, I'm not sure if it's property, but if we have log base 2 of 2, if I ask you to evaluate that, could you do that? You tell me what that equals? We did that yesterday. It's going to equal something, we just don't know what it is. So let's put x. How would you evaluate this? Yeah, change it to exponential, so 2 to the x power equals, so 2 to the x power equals 2. What does x have to be? 2 to what power gives me 2? 1. X has to be 1. Do you notice that our base and our argument are the same? If that's the case, that expression is going to be 1. And that will help you to solve a lot of things. Otherwise, you're just going to have to go off to the side and evaluate it. But if you can remember, if your base and your argument are the same, then that expression, that logarithm, is equal to 1. That'll help you a lot. Okay, so let's look at our handout and fill in some things. The first property, here are the properties here on your handout sheet. It says the products property. I just gave you an example. Did you guys write that down in that column? That would be this example right here. Write this down in the example column, please.
For product property?
For products property. So multiplying our arguments, we can write it out in expanded form where we're adding our logarithms. Okay, the quotient property down below. Okay, the quotient property says that if we're dividing our arguments, that we're really subtracting. Isn't there another time that when we divide, we subtract? Exponent rules. If you divide variables, you subtract the exponents, don't you? So that'll hopefully help you remember. Now for an example, oh, it doesn't really matter, let's make up one. Log base 6 of 1/5. So if we write that out in expanded form, it's going to be log base 6 of 1 minus log base 6 of 5. That's the quotient property. Last one is called the power property. base still. M is our argument. P is our power. P for power. In the power property, when we're using logarithms, we don't like to have a lot of exponents. So what we do is this P is going to come to the front of our logarithm. So on your paper, it looks like log, doesn't it? You see that? There was P-L-O-G. It's really P times log base B of M. It's not really log. P times log. So as far as an example, let's say we have log base 6 of x to the third power. We can write that exponent of 3 in the front. So it would be 3 times log base 6 of x. We're going to use these properties to help us solve some things today. The first 5 problems are on your front. Looks like the last four on the back side. So let's go back to the PowerPoint. Here's our first example. It says use log base 5 of 2 is approximately 0.4307 to approximate the value of log base 5 of 250. So what they're wanting us to find is this right here. They want us to find log base 5 of 250. And we can't type this into our calculator because our base is 5. If our base had been 10, type in your calculator, will give you the answer. Otherwise, we can't do it. But we are going to use this right here to help us. So I need to change my argument. Right now my argument is 250. Can I take 2 to some power that would give me 250? Does 2 to some power give me 250? I don't think so. I don't think so.
No, you get to 256.
Okay, so we get 256, so we know that's not going to be a way we can do it. Well, let's try 2 times something. Does 2 times something give me 250? 125? Okay. So let's replace 250 with 2 times 125. Now, I'm thinking ahead. I'm going to use my product property. I know log base 5 of 2. We know that, don't we? We know that value? It's right here, 0.4307. But log base 5 of 125? I don't know that. So let's try to think of a way that we can break down 125. Another way to break it down is to use your base of 5. So 125, is 5 to some power 125? 5 to what power? The third. Okay, so let's use that. So I'm going to replace 125 with 5 cubed. How else could I write 5 cubed? 5 times 5 times 5. You could also write it that way. I don't care. This is just another way of doing it. Alright. Let's use our product property. We're multiplying arguments, so let's write it out in expanded form by adding our logarithms. So we would have log base 5 of 2 plus log base 5 of 5 cubed. Well, I believe we know what log base 5 of 2 is, don't we? That was given. So I'm going to replace this, log base 5 of 2, with what the value is, 0.4307. That was given to us. Now, what about this one?
And they just be 1.
Well, first of all, what can I do with that 3? Put it in front. So let's go ahead and rewrite that by putting our 3 in front. So we have 3 times log base 5 of 5. You know what log base 5 of 5 is. What is that?
1.
That's 1. Okay? Log base 5 of 5, we know that value. That's 1. So I have 0.4307 plus 3 times 1. Well, 3 times 1 is 3. And if we add the 2, we have 3.4307. Let's look at example 2. log base 2 of 3 is approximately 1.5850. What is the approximate value of log base 2 of 96? So I want to find what log base 2 of 96 is. I'm going to use this right here to help me. So if I can get a log base 2 of 3, I'm going to use that. Can I take 3 to some power to give me 96?
No.
I think so. How close can we get?
81.
Yep, I think 81 is the closest we can get. All right, so let's try a different route. Can I take 3 times something to give me 96?
Yeah.
3 times what?
32.
So 3 times 32. All right. So I use my 3. The other thing I might try to use is 2. Does 2 to some power give me 2? Excuse me, does 2 to some power give me 32? 2 to the 5th power, right? So let's replace 32 with 2 to the 5th. So we'll use our properties of log. We have log base 2 of 3 plus log base 2 of 2 to the 5th power. Now we know what log base 2 of 3 is, don't we? That's given to us. What is that value?
1.5850.
Plus, here we have log base 2 of 2 to the 5th power. Well, what can we do with that 5? Move it to the front. So 5 times, well, we know what log base 2 of 2 is. What is log base 2 of 2? 1. We said if our base matches our argument, the value is 1. So, of course, 5 times 1 is 5. And 1.5850 plus 5? 6.5850, right? I want to do a division one with you, but let's jump down to example 4, please. So this is example 4. Given that log base 3 of 7 is approximately 1.7712, and log base 3 of 5, that should be a base 3 right here, of 5 is approximately 1.4650, approximate the value of log base 3 of 7/5. We know what log base 3 of 7 is, correct?
Yeah.
And we know what log base 3 of 5 is? So let's write it in expanded form using division. If we're dividing our arguments, what do we do with our logarithms? Subtract them. And of course, it's always top minus bottom. So log base 3 of 7 is approximately 1.7712. And log base 3 of 5, approximately 1.4650. So if we subtract these two values, 1.7712 minus 1.4650. It's approximately 0.3062. Are there any questions with using those 3 properties that we learned? We're running out of time, so we do need to move to the back side. If you would move back there, would you please? Hang on just a second. Okay, so we are not going to move on. We'll save that for next Wednesday. These are the problems that we're going to try using our properties of logs. Remember, if you are multiplying your logarithm?
Subtract.
Subtract. You have an exponent on your argument. Where can you put it? In the front. And if your base matches your argument, what's that value?
1.
Cameron,